Hello everyone, I'm going to describe my second activity that involves the measuring of trees in a forest. The goal of my activity is to get students thinking about real-world applications of trigonometry. My activity is not based on results, but rather the correct procedures and thinking going into getting the results. Students will be asked to measure the height, circumference, and give a rough estimate of the volume of a tree. They should be able to complete this by using equations and knowledge they have used in the past, such as the law of sines, using a measuring tape to measure the circumference of a tree, and roughly estimating the volume of a tree using the area of a cross-section and the known height of the tree. I developed this activity on the premise that students would be working in groups and trying to complete a given task without instructions. Students would be given the end goal and of eventually figuring out a rough estimate of the volume of a tree, and from there they would be in charge of the proceedings of their group. I will provide them with a 100-foot measuring tape, a modified protractor which would have a paper tube on the bottom of it so that you could look at the top of the tree more accurately, and a string attached to the center of the protractor so that you could measure the angle while looking at the tree. This is a rough outline of what the project would look like. You would have a tree of unknown height here. You would have a student of a known height. The student would look at the top of the tree through the paper tube on the protractor. They would then, using the string, calculate the angle that would be here, and then from there, knowing that this is a 90-degree angle, they could find this angle. Using the law of sines, they could go sine A over A equals sine B over B. They know this distance because they can measure with the tape measure. When they find out what A is, they then add their height. This gives the total height for the tree. The next step would be measuring the circumference of the tree, and they would only have to take the height, the circumference of the tree using the tape measure. After that, they can determine surface area of a given cross-section by dividing it by pi, and then dividing that again by 2, and then multiplying that answer by, in the equation, pi r squared. This would then give them the area of a cross-section, and after they get the area of the cross-section, they can multiply it by the entire height of the tree they calculated, which would give a rough estimate of the volume of a tree if you include branches and other appendages on a tree. I would not give them any instructions to go off of for this activity. Instead, I would be available to answer their questions, and instead of answering their questions with the next step they would do, I would ask them leading questions trying to get them to determine the next step on their own. I believe this leads to a more comprehensive understanding of the concepts I'm trying to teach them, and in doing so, I'm hoping it will intrigue and interest them more so that they can learn the material better. For grading purposes, I would require that students, to receive full credit, write down their procedural outline, show their work and calculations, and then write a brief description or conclusion about what they did. Each student would have to write these down on their own piece of paper and then turn it in at the beginning of the next class. I believe this activity would be an adequate assessment on students' knowledge of trigonometric functions, and although the results would not be 100% precise, this would still teach the concepts I would want them to learn.